Okay, so good morning, guys. Welcome to second day of class. Today we're going to continue with the same topic, seeing the what we need to review before we start fully on the topics of 8th grade. So yesterday we saw the rules of signs, then we saw orders of operations, and we did a couple of exercises. We said that we were going to be able to skip some steps, okay? And today we're going to see another part that's really important for this topic, okay? Remember, we place the date always. Today is August 31st. We place the date so we can remember what we're doing, okay? And today we're going to see something that's really, really important, and it will be like really important for the rest of this school year, and that is the law of exponents. Okay? And the law of it, and after that, we're going to include the variables. Right now, we keep it simple, okay? Law of exponents, okay? We have several laws. I'm going to do it handwritten, okay? The first one is when we have same bases, okay? Multiplication of same bases. Okay, multiplication of same bases. And that's the first one that we're going to do. And what are we going to do? When we have multiplication of same bases, we are going to add the exponents and copy only once the term or the variable, okay? We're going to say the term. If we're going to leave it in exponential form, remember we have two types of forms. One is exponential form where we leave the number with an exponent, and the other one is the extended form, and it is when we simplify that number to the exponent, okay? And remember, exponent is an abbreviated way of writing a multiplication between the same number, okay? So 2 times 2 times 2 is the same thing as 2 to the cube because it's repeated 3 times. Okay, so in this case, if we have, for example, like I said, 2 to the cube times 2, this is a times, okay, let's times 2 to the 4th power. In exponential form, this is going to be 2, 3 plus 4 to the 7th power. And we leave it in exponential form. This is exponential form. Now, if we want it in an extended form, that will be the simplification, and it will be like multiplying 2 7 times. We multiply the big number as many times as the small one says. In other words, we multiply the base as many times as my power says, as my exponent says. So we're going to multiply 2 times 2, that is 4, times 2, that's 8, times 2, that's 16, times 2, that's 32, times 2, that's 64, times 2, that's 128. So 2 to the 7th power is 128, okay? And that is multiplication of same base, okay? We saw that last school year. Okay, that's the first one, multiplication of same bases. Now we're gonna say division of same bases. And these laws of exponents are gonna be also the same thing when we include the variables, okay? So division of same bases. If with multiplications we add in here, we're gonna subtract. We subtracted exponents, but this has a little trick. Remember, we subtract the exponents wherever the exponent is greater. Okay, that's it. We'll subtract the exponent wherever the exponent is greater. Okay, and we copy once the term. Okay, so an example for that is going to be if I have, let's say, 5 to the 5th power over 5 to the square. Okay, so I got 5 to the 5th power and 5 to the square. I'm going to subtract wherever my exponent is greater. Where is it greater? Numerator or denominator? Where is it greater?
numerator.
In the numerator. So I'm going to copy the term once in there, and I'm going to subtract 5 minus 2, that is 3. So
3.
5 to the cube. This is the exponential form. Now the extended form, it will be the multiplication of 5 3 times. Not 5 times 3. It's not 15. It is 5 multiplied 3 times. How much is that? Mm-hmm.
125.
125. Perfect. Okay, this is one type. Let's do another type. Let's say, for example, 6 to the 4th power over 6 to the 6th power. Where should I subtract? Where is the exponent greater? In the numerator or in the denominator?
In the denominator.
In the denominator. So I'm going to copy the term in the denominator once, and I'm going to subtract 6 minus 4. That is 2. But I cannot leave the fraction with nothing in the numerator. So I'm going to place
an imaginary 1.
a 1. Awesome. Okay. So now this is the exponential form. I'm going to say 1 to the what? How much is 6 to the square?
36.
36. Perfect. Perfect. So 36. Awesome. Perfect. And that's it. That is a division of same basis. Make sure that when you subtract in the denominator, you place a 1 if there's nothing left. Okay. Like if there's nothing left, then you subtract there. Okay. That's the second rule of exponents, the second law. Let's see the third law. And this is the easiest one. 0 power. Can anyone tell me what does the 0 power says? Anyone? What does the 0 power say? Aaron Ingles has no audio. There he is. Hello, Aaron. Aaron, what does the 0 power say?
Miss,
Yes?
that anything being affected by a 0 will be a 1.
Exactly. That anything. Thank you, Josue. Anything to the 0 power will always be 1. So that's what we're going to say. Anything to the 0 power will always be 1. Okay, it will always be 1. So it doesn't matter what you have. You can have, for example, a bracket, a parenthesis, and 10 to the 15th power, the 13th power divided by 2 to the 4th power, plus 8 to the 11th power, but everything is to the 0 power. This is going to be 1. You do not do nothing. You do not solve anything from the inside, because just like Josue says, it is always 1. Always. It's going to be 1. Okay, so you don't do nothing about that. Okay, we cool? We good? Yes? Okay. Now, we're going to do another one that's called power of a power. Okay, power of a power is when we have an exponent outside of parentheses affecting something that doesn't have any other operation, okay? And no operation at all, and it will be affecting that, okay? So if there's an operation, you cannot use this type of powers of a power. It has to be an expression that has nothing more, okay? And what do? Power of a power is basically the distributive property, okay? We multiply the power on the outside of the parentheses, outside the parentheses, and this. Okay, we multiply the power outside the parentheses times everything inside the parentheses. Times every power, let's say times every power inside the parentheses. Okay, so let's see an example. If I have, for instance, 3 to the second power to the fourth power. So I'm going to do the distributive property. In this case, I'm going to multiply this 4 times the 2, only times the power, power times power. That's called power of a power. So I'm going to have 3 and 2 times 4, that is
8.
Okay, so this is going to be 3 to the 8th power. And if we do that in an extended form, we are going to get a really big number because we're going to multiply 3 8 times. So it's going to be 6,561. Okay, so 3 times 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 3. And it gives us 6,561. That is power of a power. Now, let's say, for example, the only case that we can do power of a power if we have another operation is if we have a multiplication. For example, we got 2 to the 4th power times 3 to the 2nd power and everything to the 2nd power. Let's make this smaller, okay? Let's make this to the cube. 2 to the cube times 3 to the square and everything to the square. In this case, we can do it power as of a power, okay? Just like we did in the previous one. You can see it as a multiplication. We can multiply it here. We can multiply it times this other exponent, and we get 2 to the 6th power, because 3 times 2 is 6, times 3 to the 4th power, because 2 times 2 is 2. Okay, and since they are not same bases, you need to leave it like that if it's an exponential form. You cannot do anything else because it is exponential form, okay? And there are different bases. You cannot say 2 to the 10th power or 3 to the 10th power because it is not the same thing. Are we clear with that? Okay, you cannot do nothing more. But I can have the answer in extended form. And the answer in extended form is going to be 5,184. You can check that if you want. I'm pretty sure that you're not going to want to, and you're going to trust me. So that's the final answer, 5,184. And that is the fourth rule of, or the fourth law of exponents. So we have multiplication of same basis, division of same basis, 0 power, power of a power, and we're missing 1. Which one are we missing? You remember? You remember which one are we missing? So Fernando, your camera. So do you remember?
Negative exponents.
Exactly, negative exponents. We're missing negative exponents. So no, it says they're asking over here in the chat if the exponent outside the parentheses doesn't affect only the exponent like on the left. No, the exponent outside affects every single thing that's inside the parentheses as long as there is no additions or subtractions, okay? If this was 2 to the cube plus 3 to the square, a plus, you cannot do power of a power because there was an addition. You can do it in multiplications, okay? Or even divisions, but not additions and not subtractions. Yes.
Can you put what we copied yesterday, like for 2 seconds, please?
Sure. This are the exercises.
No, that.
So that's what we saw yesterday. We saw PEMDAS, and I gave you that little tip. So for right now, we're seeing the
Thank
lots of
you.
exponents. You're welcome. And we're missing one, which is the negative exponents. And instead of going further down, I'm going to move this a little bit there. So it fits. Okay. So we're going to work right now with negative exponents. That will be the last law. Okay, what does negative exponents tell you? Remember, in math, we are going to find in math in every single school year that you're going to have math in, we're going to find, Jose Fernando, your camera, negative exponents. But for us, it's going to be easier to work with positive exponents, okay? We will always like to work with positive exponents. So if I have a negative exponent, how do I make it positive? Okay, so we make positive exponents this way. That's it. We make exponents positive by passing them to the opposite side in a fraction. Okay, so let's begin with an example. Let's say that I have 3 to the negative 2 power. And I don't want to work with negative exponents. So I'm going to say that this is going to be, I'm going to add an imaginary 1. So I can make it a fraction, okay? So I can, this is a fraction already, and I'm gonna pass this 3 to the opposite side. It was up in the numerator, I'm moving it down to the denominator. So I'm going to have in the denominator, the one that I have already there, times the 3, and I copy the exponent positive. If this one doesn't disappear, the red one that was invisible, it doesn't disappear. It's still there. I'm just multiplying it, okay? But I cannot leave a fraction without a numerator. So I place an imaginary 1 over there as well. Now, I'm not done. Why? Because I got a multiplication in here. However, anything multiplied by 1 will be that same thing, right? So basically this 1, I don't need it. So I can just go ahead and say that this is 1 over 3 to the square. And this is the exponential form. The extended form is going to be 1 to the over 9. 1 over 9. Because 3 to the square is 3 times 3. And it's 9. It's not 3 times 2. It's 3 times 3. And this is how we make it positive, okay? This is exponential. This is extended. I will be asking you which way I want you to do it, okay? Now, second example. I have, for example, 2 over 5 to the negative 3rd power. Okay, so this is already a fraction. So I don't need to do the step that I did over here of adding an invisible 1. I just go ahead and move this 5 to the numerator. Okay, so I'm going to have 2 times 5, and this exponent that was negative now becomes positive. And this is the exponential form. I cannot do anything else because these two have different terms. They're different bases. One is base 2 and the other one is base 5. So I cannot do anything else in there, but I can do the expanded form. I can say 2 times, I'm going to use the parentheses, 5 to the cube. We had it over here and it was 125. Daniel gave us the answer. And I can still continue to simplify this. And this is going to be how much? 2 times 125. How much is it?
Two hundred and fifty.
Exactly, 250. And this is the extended form. This is the extended non-simplified form. And this is the exponential form with positive exponents only. And this is exponential form with negative exponents only. Now, just for common knowledge, let's do an exercise where we have to use more than one of this exponent, this laws, okay? I'm gonna do it in green, okay? So let's say that we have 2 to the cube times 3 to the square, negative square, over 2 to the negative 1 times 3, and that's it, times 3. We're going to do it like that. And then we're going to do a power of a power that's going to be 2 to the square. And we're going to simplify this exercise, okay? We're going to simplify this exercise. I'm placing a little star there so you know that it means that it includes more than one of the rules, okay? So what are you going to do? First, always, first, make the exponents negative, make them positive. So this 2 to the negative 1 has to come to the numerator and be positive. And this 3 to the negative 2 power has to come down here to make it positive, okay? Now, before I do that, this 3 has no exponent. So if there is no exponent, what power does it actually have?
Imaginary 1.
An imaginary 1, exactly. So I'm adding that imaginary 1 exponent in there. I'm going to continue then. So I'm going to open the big parenthesis. This 2 is already positive. So 2 to the cube times this 2 is coming up positive, and I'm leaving the exponent 1 in there. Okay, 2 to the 1th power. Then this is negative, so I'm moving that down to the denominator, 3 to the 2nd power times, and I have already a 3 to the 1 power over there. So 3 to the 1 power and everything to the square. Now I have multiplication of same basis. I can multiply them right there. Okay, so I can have now 2 to the cube times 2 to the 1 power. That is how much? 2 to the cube times 1. How much is that? 2 to the cube times 2 to the 1 power. How much is that?
To the 4th.
The fourth power.
To the 4th power, because I add them. Remember, same basis, I add. So 3 plus 1 is 4. And then at the bottom, I got 3 to the 3 to the what power?
The 3rd power.
Third power.
To the 3rd power. And everything goes to the square. Now, since these are not same basis, I can go ahead and do power of a power already. And I need to multiply this exponent on the outside times every single exponent on the inside. So I'm going to multiply times this 4, but also times this 3, okay? So I'm going to have 2 to the 4 times 2, that will be 2 to the 8th power over 3 to the what power?
6.
6 power.
2 to 6 power, correct. And this is the exponential form of the exercise that we just simplified, okay? Can we simplify it in a different way? No, we can just do it extended form. but we're not going to do extended form because there's no simplification. Okay, we're going to leave it there. That's it. We're going to leave it in exponential form. And that's it. And that's how we use more than one law in one same exercise. Are we clear? Yes? Okay. Now we're going to place the name of the topic. What's the name of this topic, guys?
Law of exponents.
No, loss of exponent was what we saw right now, but it includes everything that we have seen, rules of signs, orders of operations, and loss of exponents. What is the name of this topic? It's not in the book. None. It is called solving numeric expressions. Solving numeric expressions. That's how it's called, okay? Only that. It's not in the book like this. It's not in the book like this. It's called solving numeric expressions. Afterward, we're going to add the variable, so it's going to be solving algebraic expressions. Right now, it's numeric because we only have numbers. Once that we add letters, variables, then it's going to be called algebraic expressions. And this is the first topic that we are going to be seeing. Questions?
Now, Miss, can you please put the final negative exponent, please? Explanation, the last one. Thank you.
So any other question about that? But the topic itself? No? Okay, then this is our first topic.